Assalamualaikum warahmatullahi wabarakatuh. We meet again in our second topic, data and data representation. So at the end of the topic, you should be able to explain what is data, what is information and processing. Okay, the second one is what are bits, bytes and words. And then the last one will be the ASCII code and Unicode. So what is data, information and processing? Let's see. A computer process and store all forms of data in binary format. Okay, computer do not speak our language. Human communication include languages, images, and sound. So we can speak, we can see pictures, and we can hear voices of sounds. So we have different data formats. So the specification for converting data into computer usable form. Okay, define the different ways human data may be represented, may be stored and processed by a computer. That is what is data formats. So let's see example in real world. We have data and we have an input device. Let's say your keyboard, and then you input the data, it becomes the data inside the computer. You type dear mom, okay, using keyboard, but the computer actually understand it in this form, 10 and so on. And then you take pictures from your digital camera and you put into your computer, and the computer also understand that picture in the binary form. Okay. So the cycle of information processing, what is it? Information processing cycle is the series of input, process, output, and the storage activities. So from input, okay, the data that you collect, and then it will be processed, go to the processing. Of course, when something is processed, it will become an output. So your output will be the information that is processed from your data, which are facts. So let's see an example here. We have a cashier. Okay, step one, we have a cashier. You go to supermarket, you buy things. So the cashier scans or enter the item purchased and the amount received from the customer. Okay, these items are entered into the computer as data. Okay, data. So what did you bought? You bought 2 medium sodas, 1 small turkey sub, 1 Caesar salad, 1 bag of chips, 3 cookies, and you give the cashier $20. Okay. Here, when the cashier scan your barcode, the barcode of your product, so the cashier can see the price for each of the item. So what happens? Step 2, the computer, okay, the computer you scan, it goes the data goes into the computer. So the computer will receive the entered data, it will store the data, and then it will processes the data into the information. Okay, the information will result to what? Then it will store the resulting information. So let's see. It stores entered data. The computer will computes each item. Okay, $1.49 multiplied by 2. Okay, and then so on. So multiply the quantity ordered with the each item price. Okay, and then it will organize the data, and then it sums all the item total prices to determine your order total due. So the amount that you have to pay is $13.12. here. So the computer will calculate change because you, the customer, give the cashier $20. So $20 subtract by 13.12 cent, you will get a balance of a change of $6.88. And then it will store the resulting information. So your information is the output. So the cashier will give you a receipt that is printed, correct? So this is an example of the receipt that you will get when you buy goods from the supermarket or any other shops. So what is data? Data is unprocessed facts and figures. Okay, it is a fact. Figures. The price of crude oil is $80 per barrel. Okay, so this is the figure. What is it? Price of crude oil. For how many units? Per barrel. Okay, that is fact. Information is the data that has been interpreted or has been processed. So what can we understand by that information? Okay, we see this price this week maybe. Okay, this price this week. Okay, maybe we can say that the price of crude oil has risen from $70 to $80 per barrel. Okay, last week the price is only $70. Okay, but this week the price is $80. Okay, that is an information after it has been after data has been interpreted. And then what is knowledge? Knowledge is the information, okay, not the data. The information combined with your experience and also your insight. Okay, so when combined with your experience and insight, you can see that when crude oil prices go up by $10 per barrel, it is likely that gas prices will also rise by 14 cents per gallon. Okay, the knowledge can only be generated with the experience and the insight, okay, by that person. So data is applied for a purpose, it becomes an information, and then when it is built up and processed, it will become a knowledge, okay, interpreted by the making sense of data and information, Elsevier 2007. So the computer process data into information. Okay, this is the data inside your computer that you give to your computer. Okay, collection of unprocessed items can include text. You enter text, you enter numbers. Okay, you plug in or you enter images, audio and video. These are the data. Then the computer process the data, so it will convey meanings and is useful to people. The data is encoded by assigning a bit pattern to each character, digit, or multimedia object. So there are many standards exist for encoding. Character encoding, example is ASCII. Image encoding, example is JPEG. Video encoding like MPEG-4. Okay, this is only example. There are many more. So types of data, we have alphanumeric, we use this one, ASCII standard, ASCII standards or Unicode standards. We have image, we have JPEG, we have GIF, we have PCX, we have TIFF, we have PNG and so on. Motion pictures. We have MPEG-2, QuickTime, sound. We have Sound Blaster, we have Wave, we have AU. Outline graphics or font, we have PostScript, we have TrueType, and we have PDF. Okay, when you will ask this type of question, you must be able to determine which standard goes to which type of data, or what are the standard used for certain type of data. So this is the example, the color value, okay, black, the code, the color code, the color RGB, okay. For ASCII code, A in binary, uppercase letter is different with A lowercase letter, you see, okay. But you don't have to memorize this one. You can find the information, the ASCII table inside your internet. And then the data storage and compression. Okay, we use compression to reduce the size of data to save space of transmission time. So there are two categories of data compression. We have lossless, we have lossy. So lossless compress the data exactly to its original form. Lossy compression involves a certain amount of data degradation. Okay, it degrades the data. So most common in multimedia application. Okay, if you don't do this, therefore, even though you compress, the size is still big. So when question asks you, define lossless data compression, okay, 4 marks. I want to ask you, is this information enough for you to answer that kind of questions, class? Okay. So the answer is no. This is not enough. You must try to find the information inside the internet. Google lossless data compression. There are many informations inside the Google. Okay. And then the data integrity. Data integrity actually refers to the reliability, the trustworthiness of the data throughout its life cycle. Okay, your data can be valid or invalid, or the process of ensuring and preserving the validity and the accuracy of data. So you must make sure the security of protection of your data. It will involve access to files. Okay, we have access control list. What is access control list? Anyone? Access control list? No one. It is a function, okay, that watches incoming and outgoing traffic and compares it with a set of defined statements. Okay, the main idea of the ACL is to provide security to your network. Okay, where without it, any traffic is either allowed to enter or exit. So therefore, it will be vulnerable to unwanted and dangerous traffic. Okay. And then you can protect files from being written to or execute. Okay, we have password protection and we have keyboard locking. So data integrity is equivalent to quality of data. So how do we measure the quality of data? By its correctness, by its completeness, by its consistency, by its validity, and by its compliance. There are many more, okay, but we focus to these 5 characteristics, okay. So the problem, the issue that we have with our data. Okay, human us make errors during data entry. This is normal, very often happen. Okay, you want to type X, you type C. Okay, you want to type 3, it become 4. So errors when data is transferred. You already done doing data entry. When you transfer the data, there are errors. You have software bugs or viruses. You have hardware malfunctions. And the most that we cannot predict is the natural disaster. Okay, flood, storm, tsunami. So what are the solutions? You must make data backups regularly. Okay, we have to set the security, we set the control access to the data. We want to design user interfaces that validates data input. And then we use error detection and correction software when transmitting the data. So next is the second subtopic, bits, bytes, and words. Bits is the basic unit of information in computing and telecommunication. Okay, in computing, bit is defined as variable or computed quantity that can only have two possibilities. Okay, these two values are often interpreted as binary digits and denoted by the digit 0 and 1. Okay, this is bit. The second one is bytes. Byte is actually a unit of digital information in computing and telecommunication that commonly consists of 8 bits. Okay, you have bit 0 and 1. So 1, 0, 0, 0, 0, 0, 0, 1. 8 bits is equivalent to 1 bytes. Okay, let's see this one. 0. Okay, there are 8 bits equivalent to 1 bytes. Whatever the number, 1, 1, 1, 1, 1, 1, 1, 0, equivalent to 1 byte. Okay. So a byte was the number of bits used to encode a single character of text in a computer. And for this reason, the basic addressable element in many computer architecture. And then what is word? In computing, word is a term for the natural unit of data used by a particular computer design. A word is simply a fixed size group of bits that are handled together by the system. Okay, the number of bits in a word, okay, word size or we call word length, is an important characteristic of computer architecture. So 1 byte equivalent to 8 bits. So I want to ask you, one word equivalent to how many bytes, equivalent to how many bits? Please answer this. Numbering system. Okay, we have different base. We have decimal, we have binary, we have octal, and we have hexadecimal number. Okay, this is an example of calculating the number. This is the point, decimal point, binary point, octal point, hexadecimal point. Okay, 1 is actually 10 power of 0 for decimal. 1 is actually 2 power 0 in binary. In octal, it is actually 8 power 0. 1 is actually 16 power 0 in hexa. Okay. So you will learn this later in depth in your CSC159. So let's see the basic only for this course. So the number bases we have radix, okay, not the kopi that you drink when you go to warung, to coffee house, okay. It is a single lowercase letter appended to the end of each number, okay, that is to identify its data type. Okay, let's see this one, H. H is actually a radix for hexa. Q or O is actually a radix for octal. Okay, binary B is radix for binary. Okay, decimal we don't put the radix because we use decimal in our daily life. So 45 in hexa will be written as 45H. 76 in octal will be written as 76O or 76Q. Binary, these numbers will be written as this number and with B at the end of the number. So this table shows you the equivalent values for decimal, okay, in binary, octal, and hexa. So we use only 4 bits first. Let's understand this. 0 is 0, 0, 0, 0. Of course, octal is 0, hexa is 0. 1, binary is 0, 0, 0, 1. Okay, if only 4 bits, it is 0, 0, 0, 1. But if it is 8 bit, therefore it will become 0, 0, 0, 0, 0, 0, 0, 1. Okay, so just focus with the 4 bits. And then 2. How come you get this one? 0, 0, 1, 0. Okay, the easiest way is to use your calculator. Punch your calculator, go to the base, and then type decimal, convert to binary. You will see this number. Okay, octal 2, hexa 2. Okay, let's see until 7. Okay, 7, 0, 1, 1, 1. And then octal is still 7, hexa is still 7. But when we see 8, okay, ignore this binary. Let's see this one. Octal become 1, 0. Hexa still 8. Okay. 9. Octal become 11. Hexa still 9. 10. Octal become 12. Hexa is 8. Okay. See, that is interesting. So how do you convert these numbers? Okay, the easiest way is to use your calculator. But then there is a way to convert. I will give you the slide for conversion later. Okay, if you need to convert. It is actually focus in the CSC159 subject. Okay, class? In general, actually, decimal, it is a base 10, okay? Let me clear first all the thing. Okay, decimal is base 10, binary is base 2, octal is base 8, hexadecimal is base 16. Okay, so 10 meaning you have 10 numbers from 0 until 9. Okay, binary we only have 2, so 0 and 1. Octal we only have 8, 0 until 7. And 16, we have hexadecimal, we have 16 digit. So we have 0 until F. Okay, after 9 continues with A, B, C, D, E, F. If you count using your fingers, you will get that one. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, D, E, F. There are 16 digits. Okay. The number of different symbols required to represent any given number. Okay. So base 2, binary, base 8, octal, 10, decimal, 16, hexa. 0 and 1 for binary, 0 until 7 for octal, 0 until 9 for decimal, 0 until F for hexa. Remember this one. For a given number, the larger the base, the larger the base. Okay, ni. 2, 8, 10, 16. The larger the base, the more symbols required. Okay, the more symbols required. See, we don't know what is A before this, but A in hexadecimal is actually 10 in decimal. So, it said that the larger the base, the more symbols required until F for hexa, but the fewer digits needed. Okay, let's say you want to write 15. 15, this is actually a decimal number. Okay, 15 in decimal number is equivalent to what? Punch your calculator, class. See your calculator, punch your calculator. Let's see the conversion. Okay, try to go to the conversion. 15. You type decimal 15 and then go to hexa. It is actually equivalent to F base 16. Okay. So equivalent to what in base 2? Equivalent to 1111 base 2. Base 8? Anyone? Equivalent to 17 base 8. Okay. You want to know why? So for the F, you must memorize. After 9, it is 8. So 1 is a number, okay? 1 is 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 10 in decimal. But in hexa, this is A. Okay, 10 is A. 11, B. 12, C. 13, D. 14, E. 15, F. Okay, that's why I told you, you have to memorize. Okay, you can use your fingers. Tak ada fingers, ada kan? Kalau tak cukup, ambil lah jari kaki. Tak cukup juga, ambil lah apa-apa lidi ke, batang aiskrim ke, suka hati lah. Asalkan dapat faham. Setiap hari kelas saya letak macam tu. Kelas bukan kelas saya je, kelas saya tak ni sangat. Kelas 159 nanti, you all letak, you all punya lidi tu, kira. Okay, so to convert from 15 to binary, how? So the easiest way is to use your calculator, or you can memorize, or you can calculate. Okay, 15 divided by 2 is how many? 7. Okay, no balance, no remainder. Sorry. Why my don't want I don't know why my, okay. Okay. 15 divided by 2 is 7 with 1 remainder. 7 divided by 2 is 3 with 1 remainder. 3 divided by 2 is 1 with 1 remainder. Okay, 1 divided by 2 cannot. So, there is 1 remainder. Okay. So, we start from the bottom to the up. So, we get 1, 1, 1, 1. That is the number. 1, 1, 1, 1. Understand? Okay. Let's see the octal. I don't know what is wrong with my tablet. Okay, let's see. I want to erase this one. Okay. So, the number 15 divide by, we want octal, right? So, 15 divided by 8 is the, you get only 1, but you have a remainder 7. Am I correct? So, 1 divided by 8 is 0 with a remainder 1. So, therefore, the number, the answer will be 1, 7 base 8. Okay. You will see this later in the video that for the conversion. I will give you the link. So, let's see this fact. The larger the base, which one is larger? This one. The larger the base, the more symbols required. Okay, this is correct, F. But the fewer digits needed. See, F only 1 digit. Okay. 15 base 10, 2 digit. 17 base 8, 2 digit. 1111 base 2, 4 digits. Nampak tak? So, makin kecil base 2, makin kurang simbol yang kita guna, 01 je. Tapi, makin banyak digit yang kita perlu tulis. So, the binary system, early computers was designed using the decimal. Okay, we have Mark 1 and we have ENIAC computer, remember? And then we already learned about John von Neumann. Okay, here it proposed the binary data processing in 1945. Okay, so therefore we have simplified computer design that is used for both instruction and the data. So the natural relationship between on-off switches and calculation using Boolean logic. So on is true, or yes, or 1. Okay, off, when your bulb is off, therefore it means false, it means no, it means 0. Understand? And then the computer stores both the instruction and data as individual electronic charges. Represent these entities with numbers requires a system geared to the concept of on and off or true and false. We already know that binary is a base 2 numbering system, either 0 off or 1 on. So computer stores all these instructions and data as sequences of binary digits. Okay, let's say you type ABC, but actually the computer read this binary digit. Why? Because it stores all instruction and data as a sequence of binary digit, not as ABC. So octal system known as base at 8 numbering system. You already seen this one. Only 8 different digits available. Start from 0. Okay. So there is no 8 in octal system. The maximum is 7. Decimal system, base 10. There is no 10 actually in decimal. Actually, it is 0 until 9. Next, we combine with the 1 and 0. So we use a system based on decimal digits to represent numbers. Each digit in the number is multiplied by 10 raised to a power corresponding to that digit position. Okay, you see this one in the table that I show you, the blue one, I think. Okay. And then the hexadecimal system is a base 16 numbering system, used not only to represent integers but also used to represent sequence of binary digits. Okay, let's see this one. Example of hello world. Hello dash and space. Okay. H is an uppercase letter. Hello world. So we see this table. This table is called ASCII table. Google for this one. Okay, where is H? H in binary is for ASCII table, okay? H is 1001000. Alright? 7 digit 1001000. Here it represents in 8 digits, so that's why there is a leading 0 here. So the number is 1001000, equivalent to 48 in hexa, equivalent to 72 in decimal. Okay. E is this in binary, 65 in hexadecimal, and 101 is decimal. E is the lowercase letter e. Where is E? Here. Okay, 101, 65. See? So, when you see this one, where is the... I did not include this symbol in this table, okay? But there is a character comma in binary, in hexa, in decimal. There is also space in binary, hexa, and decimal, and so on. So this is an example of what the computer understands, okay, when you type hello world. So let's see the next and the last subtopic of this topic. Okay, we have ASCII code and we have Unicode. The alphanumeric representation, okay, where the data is entered as character, number digits, and punctuation are known as alphanumeric data. So there are 3 codes, 3 alphanumeric codes that are used in common. The first one is ASCII, stand for American Standard Code for Information Interchange. And then we have Unicode, and we have also ASCII, Standard Binary Coded Decimal Interchange Code. Okay, you can see this table that shows the comparison between the ASCII code and the binary code, and ASCII code in binary and hexadecimal for the given character. You already seen this one. I already show you H. Okay, space. Okay, there are all the characters that we have will have their own binary code in the ASCII code. Alright? So you already seen that it is an acronym for American Standard Code for Information Interchange. It is a standard of 7 bit. Okay, 7 bit. The maximum is 1111111, 7 bit. The last, the character is delete. You see this one? Okay. It was first proposed by the American National Standard Institute or ANSI in 1963 and finalized in 1968. So that is why it is called the ASCII, American Standard Code. Okay. The purpose of ASCII was to provide a standard to code various symbols which are visible and also invisible symbols. In the ASCII character set, each binary value between 0 and 1 to 7 represent a specific characters. Most computers extend the ASCII character set to use the full range of 256 characters available in a byte. Okay. If you only go to 1 to 7, meaning you use 2 power of 7 or 2 power of 8 class? Huh? 2 power of 7, right? 2 power of 7. That's why when you have 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, this is equivalent to 1 to 7. Am I correct? Please use your calculator to verify. 1 to 7. Okay. But when it is said to use the most computer extend the ASCII code to use the full range of 256 character, meaning 256 character is actually 2 power of 8. Okay, 2 power of 7 equivalent to 8. 2 power of 8 equivalent to 256. Okay, so for this one, if it only use 7 bit, so 2 power of 7 is equivalent to 1 to 8. So therefore your digit will start with 0. So the maximum is 1 to 7. So you have 1 to 8 digits. Okay, here you have 256 digits. So therefore your numbers start from 0 until 255. Okay, you can store 256 characters. Okay, here you can only store 1 to 8 characters. So in general, okay, why it is extend to the 256? Because the upper 1 to 8 characters can handle special things like accented characters from common foreign languages. So in general, ASCII works by assigning standard numeric values to letters, to numbers, to punctuation marks, and other characters such as control code. And uppercase letter A is actually represented as 65 in the ASCII code. A, where is A? Here A. Okay, ASCII code for the character A is 65 in decimal, 41 in hexa. Okay, so you can search this ASCII table in your Google. Then keyboard input. Keyboard input. Key will scan codes. Okay, so the codes will be converted to the ASCII, and then the ASCII code will be sent to the host computer, and it will receive by the host as a stream of data. And then it will be stored in the buffer and will be processed. See, you type A, it understand actually this one. Okay, before it understand this, okay, it will be converted into ASCII code 097. When you use Shift A, you press Shift A. Okay, it is actually you want to enter the character A. Character A in ASCII code is 065. And then it will be processed. So in binary, the computer understand this one in binary. So Unicode, it is a worldwide character encoding standard. The main objective is to enable a single unique character set that is capable of supporting all characters from all scripts as well as symbols that are commonly utilized for computer processing throughout the globe. Okay, the Unicode use the 16-bit standard. It is a superset of the ASCII code. So, what is the usage of Unicode? To encode text for creation of password, to encode characters to display in the web pages, to encode characters that is used in email settings, and to modify characters used in documents. So, both are character codes. So, what are the differences between ASCII code and Unicode? Okay, the first 1 to 8 code position of Unicode mean the same as ASCII. Okay, ASCII define only 1 to 8 character. Okay, if it does not extend, which map to the numbers from 0 until 1 to 7. Correct? Unicode define less than 2 power of 21 characters. So how many characters that can be defined? Similarly, will map from 0 until the number of 2 power 21. Though, not all numbers will be used. Okay, there are some that are reserved. I already said this one. It is a superset of ASCII. So, the numbers of from 0 until 1 to 8. No. From 0 until 1 to 7. Have the same meaning in ASCII as they have in Unicode. For example, 65 means Latin capital A. Okay. So, when you were asked differentiate something, so better to make your point using a table. Okay. So, we can clearly see. So, the ASCII, the Unicode. ASCII has 1 to 8 code points, 0 through 1 to 7, while Unicode has 1114112 code positions. ASCII can only encode characters in 7 bits. Unicode can encode characters in 16 bits and more. ASCII can only encode characters from the English language. Okay, does not understand Latin, German, Tamil, Chinese characters. Okay, but Unicode can encode characters from virtually all kinds of languages. ASCII is known as Extended Binary Coded Decimal Interchange Code. Okay, that was developed by the IDM. So therefore, it is restricted mainly to the IBM or IBM compatible mainframes. So the conversion software to or from the ASCII is available. It is common in archival data. The character codes differs from the ASCII. Okay, see ASCII you have space 20. in hexa, but in ASCII it is 40. Not the same as ASCII. Okay, not the same as Unicode. Uppercase letter A, 41 in hexa for ASCII, but C1 in hexa for ASCII. Okay, that is all for our topic. So let's see in our next class, and make sure I will give you the questions or exercise for you for this topic later. Okay, hope you can understand. If you have any question, please feel free to contact me, okay, using Telegram or the classroom. Okay, class? See you later. Assalamualaikum.